Good morning. Good morning. The main objective of this session is to give an awareness about what is computational thinking and what is the advantage of implementing computational thinking in educational institutions such as schools, colleges, etc. through an activity called recreate a pattern found in nature. So there is an activity uh, to learn the concept of computational thinking, that is, from nature observation, the learner first choose a pattern, and they have to identify some patterns, and they have to finalize the patterns, and after that they have to recreate that pattern in Tinkercad application. So through this activity, the student can learn the concept of computational thinking. These are the contents. The first one is Introduction to Computational Thinking. So what is the definition of computational thinking? What are the four basic steps involved in computational thinking? Then learning objective. Then what are the standards we are following? Materials, grade chart, student checklist, the different types of learning such as collaborative learning, independent learning, differentiated learning, evaluation rubric such as self-evaluation, peer evaluation, and teacher evaluation. Then sample evaluation sheets, some sample students' works, instructions. Then what are the other activities after finishing this computational thinking activity? What is the next activity we are going to start? Then what are the expectations after finishing this activity? And finally, conclusion. Let us enter into the topic, Introduction to Computational Thinking. So computational thinking is a way of thinking process that involves breaking down the problems into smaller parts and creating a set of instructions that can be executed by a computer. This approach can be applied in education as a problem-solving method, where problems and their solutions are expressed in a way that a computer can also understand and execute. From this figure, we can clearly understand the four stages, the four steps involved in computational thinking process. The first step is the decomposition. Decomposition means you will break down the problem into smaller sections. From this image, you can easily understand the concept of decomposition. Let us imagine this big circle as your complex problem, and you will break down the problem into smaller sections. This stage is called decomposition. So means you are breaking down the problem into manageable parts so that you can manage the problem systematically and in a systematic and logical way. Then the second step is the pattern recognition. Pattern recognition means when you enter into the in-depth details of your problem, you can understand that there are some similarities or there are some trends involved in your problems. So again, to understand the concept, you can see there are 8 circles. Out of the 8 circles, there are 4 circles without shading, and the remaining 4 circles with shading. This is to understand the concept. That means 4 problems are following one type of pattern, and the remaining 4 problems are following another type of pattern. That means you can use one type of approach to the 4 subproblems, whereas you can apply a different approach to the remaining 4 problems. So this is what is called pattern recognition. And the next is the abstraction. Abstraction means when you are dealing with complex type of problems and its subproblems, there are some data which are very relevant to find the solution of your problem, and there are some data which are irrelevant. It is our duty to deal with relevant data only. and ignoring the irrelevant data. So dealing with the relevant data while ignoring the irrelevant data, that is what is called abstraction. That means focus on what's important. And the last step is algorithmic design or algorithm. Algorithm means uh, the step-by-step instructions to find the solution of your complex problem. That is what is called algorithm. Okay, what is the first step, what is the next step, what is this third step, like that. So the step-by-step instructions to find the solution of your complex problem, so that is what is called algorithmic design or algorithm. If you are applying these four concepts into your problem solving method, then we can say your thinking will be like a computational thinker, or I can say you are a computational thinker. Then these are the standards. Yeah, these are the standards we are following in this activity. The standards are innovative designer, ISTE standard 4, ISTE standard 5, ISTE standard 6, then CCSS grade 3, grade 6, and grade 7. So these are the 6 standards we are following in this activity. The first one is innovative designer. So innovative designer means they are using latest digital tools to create, to understand the problem, identify the problem, and solve the problem by using new, useful, imaginative solutions. They are using variety of technologies within the design process. Then computational thinker, ISTE standard 5. Computational thinker means they will apply the concept of computational thinking by breaking down their problem into smaller manageable parts, and the preparation of the step-by-step instructions so that a computer can easily execute. Then communicator, see once they will finish their activity, they they have to share their design, or they have to share the problem to the outside world, so that they will get a proper feedback from the outside world. That means they have to communicate their design, their problem, their solution to the outside world, and they have to share their solution to the outside world and collect the feedbacks from the outside world. Then the next three standards will be related to geometry and mathematics. Then we are learning computational thinking through an activity. First we will understand the concept of computational thinking, and then through an activity we will apply the four steps involved in the computational thinking process. So we are using a digital tool called Tinkercad. Tinkercad is an application that is managed by Autodesk. It's an American multinational company. Their main focus is to the preparation of digital software solutions to construction, manufacturing, educational institutions, etc., etc. So they are managing this application. Their academic wing is managing the this application, and there is another website called Instructables. There are so many contests. The Autodesk is publishing every month. They are publishing so that every student around the world can participate in that contest, and they can share their expertise to the outside world through the platform called Instructables. But before participating into that contest, they should learn different things from the Tinkercad learning application. So Tinkercad learning application is a very powerful application to learn so many ideas, so many ideas such as computational thinking, basics of robotics, the basics of designing. So uh, um, basics of design thinking, so that they can participate in the contest published in the instructable websites, and That contests are managed by the Autodesk. It's an American multinational company, I already explained. So to do this activity, we need Tinkercad application. Again, Tinkercad application is a cloud-based application. So we require computers or tablets with internet access. Then, when we are doing the activity, we require uh, we require uh, conventional or digital sketch sheets to draw, to write something. So we require digital or paper sketchbook or sheets of paper with pencil or pens. Then finally, after finishing the activity, the student will demonstrate their design to the outside world, so that they require PowerPoint, Google Slides, or Keynote. And finally, if there is a 3D printer available, we will 3D print their design so that they will get a real feel about their design physically, uh, rather than virtually. Okay, but that is optional. If there is a 3D printer is available, then we can print the design, the final solution. Coming to the grade chart. So I already mentioned I took this activity from Tinkercad Learning. It's a platform that is managed by Autodesk. um, Autodesk, a multinational American company, and in that Tinkercad Learning application, there are 18 activities. There are 18 activities that is purely related to design and technology, so that the students can learn the different concepts such as the basics of robotics, the basics of design thinking, the basics of computational thinking, basics of mathematics, basics of technology, basics of creativity, basics of innovation. So, so this is a very powerful platform to learn different concepts. And coming to this activity, I took this activity from Tinkercad Learning, and the lesson plan, I am following the lesson plan prepared by Mr. Stephen Jones. And in that lesson plan, uh, we can see there is a grade chart. The grade chart, in the sense, they are they are implementing the concept of computational thinking. It is mandatory to learn the concept of computational thinking from grade 3 to grade 8 in US children's. It is mandatory to learn the computational thinking concept uh, inside the US grade 3 to grade 8 classroom students. And again, from grade 4 to grade 9 students in UK, again it is mandatory to learn the concept. So this is a great chart for US and UK children. I am following the same standards to my children, so that they are in they are in they are properly parallel to the learning. They are doing exactly like the US and UK children's. So that is my intention. Then learning objective or I can statement. So what is the objective? So anyway, we are doing an activity. So there is there are different objectives. So what are the objectives? The first one is documentation. So after finishing the activity, the student will be able to document their activity, and they have to submit a comprehensive report to the instructor. That is the first objective. I can document the process of computational thinking, which includes decomposition, pattern recognition, abstraction, and algorithm development. Then the second one is nature observation. Observe, observe your nature, and you have to identify the different patterns. Such you can observe buildings, you can observe trees, you can observe uh, you can observe anything. Okay, you can observe anything, and you have to identify potential patterns. And finally, And finally, you have to recreate that patterns in Tinkercad application. That is the second learning objective. Then the third objective is you should use repeat block and count with block. So we are using Tinkercad code blocks, and you should use these two blocks, repeat block and count block. And the fourth one is using variables, objects, and math blocks. You should use variables, you should use objects, and you should use math blocks. Okay. The first three design activities are common to all. Actually, the main aim of doing uh, this type of common design is to inculcate the concept of collaborative learning. Okay, so there are six designs. Students have to prepare six designs, and the first three designs are common to all. These are the three designs. The first one is linear leaf pattern, then the second one is honeycomb, gridded honeycomb pattern, and the last one is 360-degree radial pattern. So if there are 15 students and those 15 students are discussing with each other and inside the computer laboratory, and they can share their ideas, they can share their viewpoints, they can give criticism, they can accept criticism, so that so that so that so that they are sharing their view, they are sharing their perspective to the outside world. In this way they will improve their public speaking skills, they will improve their active listening skills. So this is one of my intention behind the common activity, to to include the concept of collaborative learning. Okay, then after that, the next three activity, it is the duty of the student to identify three different patterns, one from linear, one from gridded, and one from radial, from the nature observation. It is purely related to independent learning. There is no connection, there is no sharing. Okay, there is nothing. It is the duty of that particular learner, so that they will understand the concept of independent learning. So what is independent learning? Independent learning means it is the complete responsibility. It is the duty of the student to finish the activity. There will be no discussion, there will be nothing. Okay, it is their duty to observe nature and identify the patterns, choose the patterns, and finally they have to recreate that pattern in this Tinkercad application. So this will promote the concept of independent learning. Okay, independent learning means we are giving responsibility to the student. Okay, what is dependent learning means the students are completely dependent on the teachers. Okay, that is not true. Okay, through independent learning, we are inculcating the concept of a research-oriented mindset. Okay, through independent learning, they are doing individually. They are doing some activities individually. That is the and in through this independent learning approach, we are promoting the concept of research, research-oriented mindset. We are promoting the concept of research-oriented mindset. That is the main intention. So, so if so, when they are doing these types of activities, they are they are actively involving the collaborative learning approach, the independent learning approach, etc. So I designed this course in such a way that they are traveling through collaborative learning. At the same time, they are traveling through the independent learning activity. Okay. And finally, the sixth and seventh one are optional. Create animated GIF for each pattern, and finally, create shapes for each pattern to be used in the 3D editor. So these two activities are optional. Then rubric expectations. The following rubric outlines the evaluation criteria and corresponding point values for the student performance. So uh, I am evaluating four outcomes. The first one is the documentation. Second one is nature observation and recreate that pattern in Tinkercad. Then usage of repeat block and count with block. And finally, the concept of independent learning. Okay, so I am evaluating The second one is recreate the pattern in Tinkercad, that is related to collaborative learning. And the fourth one is I am promoting the concept of independent learning. So through these are the four outcomes I am evaluating. And if the level of documentation is in the range of advanced or mastery, they will get 4 points. But if the student is in the range of needs improvement section criteria, then they will get only 1 point. Okay, so if the level is satisfactory, then they will get 2 points. If the student is proficient, then he will get 3 points. So through this evaluation rubric, I am evaluating the performance of the learner. The student checklist. The following is a checklist to help students complete their activity in an orderly manner. Okay, you have to you have to review these 7 points clearly so that you can finish the activities in a very systematic and logical manner. The first step is please conduct some research on the subject of computational thinking. So after my explanation, it is your duty to do some research. That is, I am promoting the concept of independent learning. You should do some research activity, because finally you have to submit a comprehensive report to the instructor. So do some research about computational thinking. Then the second one is please take a moment to observe the world around you and identify some patterns in nature. That is a nature observation. Again again that is uh, I am promoting the concept of independent learning. Okay. Then the third one is perform these three activities: linear leaf pattern, gridded honeycomb pattern, and kiwi fruit radial pattern. These three design solutions are common to all the students. Okay. So that means I am promoting the concept of collaborative learning so that they can share their ideas, they can discuss with each other, they can see they can see their friends code blocks, they can see how how their friends are doing, how their friends are preparing the design, how they are applying the four concepts such as decomposition, pattern recognition, abstraction, and algorithm to solve this particular activity. So it's completely promoting the concept of collaborative learning. Okay, then select three patterns observed in nature and corresponding designs. So this is again purely related to the independent learning. Okay, this is the next three designs. This is purely based on the research, based on the nature observation and research activity the learner has completed, and they have to recreate that design in Tinkercad application. So this is promoting the concept of independent learning. Then review the evaluation rubric. Okay, and confirm that you have received the highest possible score. The highest possible score in this activity is 16 out of 16, because the maximum score in this activity is advanced. The maximum score for advanced level is 4 points. That means, and I am evaluating four outcomes. So that means 4 multiplied by 4, 16. So 16 will be your maximum score. It is your duty to achieve maximum highest possible score. So for that you have to review the evaluation rubric thoroughly and the report preparation. And after finishing the activity, you have to submit a comprehensive report that includes all the activities you have undertaken in the field of computational thinking. All the activities means the whatever research activities you have finished related to computational thinking, and the 6 designs you have recreated in Tinkercad application, and then about the nature observation, what are the problems you faced, what are the challenges you faced, and and finally there will be a conclusion based on the activity. So you have to submit a comprehensive report to the instructor. That is the next point. Okay, and finally you have to demonstrate your design to the outside world so that you will get a proper feedback from the outside world in the sense means your customer. You are a problem solver, right? And you are a problem solver, and you are solving a problem, and you are sharing the problem to the outside world so that everybody will be get benefit from that solution. So that is the ultimate aim. We all are problem solvers, and the ultimate aim is to share the problem to the outside world, so that everybody will get benefit from that particular solution. So how you will share the design to the outside world? Through an exhibition. So finally there will be an exhibition, so that you have to demonstrate your design to the outside world. So make sure you are prepared to showcase your design work to others. See, differentiated learning. Differentiated instruction is an educational approach that involves tailoring lessons to cater to the individual interest, needs, and strength of each student. It is a student-centered method that recognizes that students have unique learning styles, abilities, and preferences. This approach allows teachers to create a variety of instructional strategies and materials that cater to the diverse needs of their students. By differentiating instruction, teachers can provide students with a more personalized learning experience. For example, a teacher might use a variety of teaching methods such as visual aids, hands-on activities, group work to engage different types of learners. They may also provide different levels of challenge to cater to students' varying abilities and strength. Differentiated instruction can also help to create a more inclusive classroom environment by acknowledging and valuing the diversity of learners. It promotes equity by ensuring that all students have access to high quality education that meets their individual needs. Overall, differentiated instruction is an effective way for teachers to help students reach their full potential by providing them with a tailored learning experience that is responsive to their unique needs and strength. So the main concept is the classroom engagement. So let us take 15 students inside your classroom. 15 students means the 15 students have their own unique learning styles. See, their learning styles are different, their abilities are different, their strengths are different, their preferences are different. So how you will engage all those 15 students with different learning style, with different abilities, with different preferences? It's a challenging question. How you will engage all those students inside your classroom? Your all of your students having different styles, different abilities, different preferences. So in that scenario, you have to apply the different variety of teaching methods. Say, if I'm continuously lecturing inside my classroom, what will happen? Say, for example, let us take another example. There are 30 students inside your classroom, and 15 students are interested in the lecturing concept, but the remaining 15 students are understanding the problem, understanding the concept by seeing something visually, some visual aids, or they are interested in doing some hands-on activities, or they are learning some concept through some practical experience. But you are completely engaging the students through lecturing only, and how they will understand. The 50% students will understand, and the remaining 50 students are not properly engaging in your classroom. The classroom engagement is a very relevant topic, and how you will solve the situation. You it is it is the duty of the teacher to use variety of teaching methods, such as some visual animation, some visual aids, hands-on activities, then group work activities, some practical oriented activities. Then only you can engage the different types of learners in the sense means their styles, the weakness, the strength, the preference, the abilities. Because so that I am acknowledging and valuing the diversity of learners. So in a classroom there are diversities, right? So I have to acknowledge and value the diversity of learners. And again, through this I am promoting the equity by ensuring that all students have access to high quality education that meets their individual needs. That means your main focus is student centric. Okay. Our main focus is student centric. Okay. Not teacher centric, student centric. That means you have to approach the concept in a personalized learning experience. Okay. You are delivering the content, but you are delivering the content so that they will feel that they are getting the concept based on their style, based on their ability, based on their strength. So it is the duty of the teacher to 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 lecture or to demonstrate, to explain the concept in such a way that the students will feel that based on my style I'm getting this, based on my ability I'm receiving this concept. So it is the duty of them. So this is what is called a differentiated instruction or differentiated learning. Again, it is purely, it is a challenging process. It is a challenging process. The designing of these types of classrooms needs experience, needs expertise, uh, so and so. Then promoting the concept of critical thinking. So critical thinking means it is developing critical thinking skills is crucial for students as it helps them to make informed decisions, understand and empathize with others, and learn from their experiences. Critical thinking is essentially a process of analyzing and evaluating information to form a reasoned judgment. It requires students to ask questions, examine evidence, consider different perspectives, and draw logical conclusions. By practicing critical thinking, students can learn to distinguish between facts and opinions, identify biases, and evaluate the credibility of sources. This skill can help them to make better decisions in all areas of life, from choosing a career path to making financial investments. Moreover, critical thinking can also help students develop empathy by encouraging them to consider other people's perspectives. They learn to take the time to understand different viewpoints and appreciate how others might feel in certain situations. Finally, critical thinking also provides an opportunity for students to learn from their mistakes. By reflecting on their decisions and thought processes, they can identify areas for improvement and make better choices in the future. This is a valuable skill that can help them to navigate challenges and succeed in their personal and professional lives. So, promoting critical thinking means you are giving a chance to ask questions. You are giving a chance them to asking evidence. Okay, they have to consider different perspectives and draw logical conclusions. They will ask the credibility of the sources. They have to understand the different viewpoints, and they have to understand the viewpoint of others. Hmm? And they will learn from their mistakes. Okay, so critical thinking is a crucial skill for students. The practice of resisting assumptions, considering alternative perspectives, and doing your research to form an objective conclusion. Okay, asking questions: where, why, what is the reason, why you are saying like that, where, who, how, which, whom, when I will get the result, where, what is the problem, what are you saying, and what is this. So asking questions, okay, asking questions critically, problem solving. Okay, in the morning, John walks out to his car only to discover that one of his tires has gone flat. He realizes that he won't be able to drive to work on it and needs to replace it with a new one. However, he also knows that it's not as simple as just taking off the old tire and putting on the new one. He needs to first remove all the nuts from the flat tire, keeping a careful track of where they go. Then he needs to jack the car up, take off the flat tire, and put the new one, being careful to align it correctly. Once the new tire is on, he needs to tighten the nuts back in the proper order and lower the jack so that the car is back on the ground. Only then can he safely drive to work without any issues on the road. A real example. Then innovation skills. What is innovation skill? Innovation skill means it is again, this is again another skill uh, like critical thinking. It's a critical component of modern day learning that is becoming increasingly important for students to thrive in a dynamic and ever changing workplace. It goes beyond traditional education. That means you are thinking not in a conventional manner, you are thinking non conventionally. It goes beyond traditional education and entails equipping students with the skills and knowledge they need to identify and solve problems creatively, adapt to changing circumstances, and persevere through challenges. Innovation education promotes a culture of curiosity. Okay, so they that will promote curiosity. Then curiosity about a particular topic, curiosity about a particular product. Then experimentation. They will do some practical things, encouraging students to think outside of the box, thinking outside of the box, and seek solutions that are not immediately apparent. By nurturing creativity, it enables students to generate and develop new ideas. So through the innovation skills, through promoting the innovation skills, they will think about new ideas, new products, new services. Then only the customer will get the benefit. Okay, so thinking innovatively so that we will get new idea, we will get new products, we will get new services that can benefit society and address pressing global challenges. Furthermore, innovation education helps students to become more adaptable, okay, resilient, and agile in the face of uncertainty and change. It enables them to embrace new technologies, learn new skills, and adapt to the new roles and responsibilities as the workplace evolves. In conclusion, innovation education prepares students for success in the modern workforce by providing them with the knowledge, skills, and attitudes they need to thrive in a complex and rapidly changing world. Independent learning environment. I already explained this concept. So again, independent learning is a process where students take charge of their own education by setting goals, monitoring their progress, and evaluating their academic development. In order to achieve this, they need to have a clear understanding of what they want to achieve, what resources they need, and how they can attain them. This approach to learning allows students to take responsibility for their own learning and provides them with the opportunity to develop their critical thinking and problem solving skills. By managing their own motivation towards learning, they can become more self aware, confident, and active learners who are capable of achieving their goals independently. This approach to learning is beneficial for students of all ages and abilities, as it not only helps them to achieve academic success but also prepares them for lifelong learning. Okay, so through this independent learning activity, this will promote the concept of research-oriented education. They will become more self-aware, confident about their skills, their strength, and they are become active learners. So that they will be capable of achieving their goals independently without any help from others. So independent learning environment. To promote independent learning, I will assign separate tasks to each student. I already mentioned there are 6 designs they have to recreate in Tinkercad from nature observation, and the first 3 designs are common to all. This will promote the concept of collaborative learning, but the next 3 designs promotes independent learning. Okay, so that is from nature observation. For example, they may have to conduct a research about yeah, they have to submit a comprehensive report to the instructor. Okay, so they have to do some research about computational activity. It's again promoting an independent learning. Okay, independent learning environment. They are preparing their own document without any discussion, without any sharing. So they are doing their job independently. They might also be asked to observe nature and identify different types of patterns. I will guide them to prepare the patterns independently so that they can understand their own strengths and weaknesses. So just a comparison between independent learners and dependent learners. So we are promoting the concept of independent learning, or we are not promoting dependent learning concept. We are promoting independent learning concept. Independent learners are self-reliant, but dependent learners are rely heavily on the teacher. Independent learners can make informed decisions about their learning, but dependent learners cannot make decisions about their learning. Independent learners are aware of their what is my strength, what is my weakness, but at the same time, dependent learners don't know their own strength and weakness. Independent learners are connecting classroom learning with the real world. Okay, so again, this activity is a very good example so that the students are so that their students are designing some patterns based on the nature observation. That means they are connecting the real world into the classroom, or they are connecting the classroom into the real world, or vice versa. So that is the one of the main advantage of independent learners. But in the case of dependent learners, they do not connect classroom learning with the real world. And this is the next point is very relevant. Independent learners takes a responsibility for their own learning. The responsibility, it's a very very important complicated term, responsibility. Okay, every time we are saying the term responsibility, but this is a very very complicated term when we are dealing with the students teaching learning process. So majority of the students are not taking the responsibility completely. They are thinking that the teacher is completely responsible for the learning. No, it is your duty. It is the duty of the students to learn the concept independently. The teacher is just a facilitator or just a mentor to guide you, to give an idea about the concept. It is the duty of you to involve more and learn the concept independently. Okay, so independent learners are taking responsibility for their own learning. And the next point is there are different strategies, okay, for learning. If we are learning something, you can apply different strategies for learning. If you are an independent learner, there are different strategies and you will find the best strategies to learn something. Okay, but in the case of dependent learners, they don't know the best way to learn something. If you know a best strategy to learn something, then you can easily learn that concept very very systematically. Okay, but so how to identify the strategy? So through a research oriented activity. If you are doing some research oriented activity, then you will understand, then you will identify the different strategies for learning. Collaborative learning, again, I already explained the concept once again. Collaborative learning is an effective collaborative learning is an effective teaching method that allows learners actively sorry to actively participate in their learning process. It involves learning working together in a group to complete assignments, projects, and other activities. This is a group activity. This method enables learners to engage with their peers, share ideas, and learn from each other's experiences. By incorporating collaborative learning into their teaching approach, educators can help learners to better process information and concepts. This is because learners can take an active role in their own learning rather than passively receiving information from their teachers. Through group discussions and other activities, learners can develop a deeper understanding of the material and see how different concepts relate to each other. Furthermore, collaborative learning teaches learners how to work effectively as part of a team. While learners are assigned to work on a group project, they learn to collaborate with their peers to understand the concepts presented to them. This not only helps learners to develop their teamwork skills, but also help them to gain deeper understanding of the material. In summary, incorporating collaborative learning into the classroom is a powerful tool for educators to engage learners and help them to better process information and concepts. It also teaches learners valuable teamwork skills that will be useful throughout their academic and professional careers. Collaborative or cooperative learning involves students working together in small groups to complete learning tasks or activities. The group size is small enough to ensure that everyone participates. Students may either work on separate tasks that contribute to a common outcome or collaborate on a shared task. To encourage collaborative learning, I will divide the students into groups of 5 and guide them through 3 patterns using the concept of computational thinking process. Through this approach, students will work together as a team and complete their activities. As I already mentioned, the first 3 activities are common to all. So inside the laboratory, inside the computational thinking laboratory, so they will sit together, they will discuss each other, and they are sharing their ideas to others. And if there are 15 students, they will get see if there are 15 students, they will get 15 perspectives from 15 students. Okay, so if I am explaining a concept, I am explaining that concept through my own way or my own perspective. Okay, maybe maybe I can explain the concept in a different perspective. Okay, so the other student can explain the concept in a different perspective. So if we are promoting the concept of collaborative learning, the student will get If there are 15 students, they will get 15 different perspectives. So that means their level of thinking, their level of uh, level of uh, understanding a concept will be more than the passive uh, teaching learning process. So that is the main advantage of collaborative learning. Okay, they are they are understanding the different perspectives of a particular problem. Okay, so I am again, see, again the thing is, the problem is same. The problem is what is the problem? The problem is linear leaf pattern, or the problem is a gridded honeycomb pattern, or the problem is the kiwi radial fruit pattern, 360-degree kiwi radial fruit pattern. The problem is same, but the perspectives are different. How they are going to approach the problem, how they are applying the concept of computational thinking into that problem. Okay, so 15 students are thinking 15, in 15 different ways. Their approach will be different, their thought process will be different, but anyway they are applying the four concepts of computational thinking, like decomposition, pattern recognition, abstraction, and algorithm. So what are the benefits of collaborative learning? Okay, the one main advantage of collaborative learning is public speaking. So public speaking inside the computer lab, they are sharing their concept to others. That means this will improve the public speaking skills. And and another thing is listening skill is also very important. Okay, you have to listen the perspective from other people's. Okay, so so through this collaboration activity, the student will acquire public speaking skills. At the same time, they will acquire the skill of active listening. Then constructive criticism. Okay, so they are in a team, in the concept of collaborative learning, they are giving criticism, they are giving constructive criticism, and they are taking constructive criticism. Okay, then help them develop in their thinking abilities. Learn Help them learn others perspectives and views. Okay, they will respect, the perspective of other peoples, they will respect the views from others, and students will become more proactive during the teaching learning process. Then teamwork. Okay, so these are some of the benefits of collaborative learning. Okay, then how I implemented the concept of collaborative learning in design and technology activity of computational thinking. I already mentioned the first three design preparations are common to all learners. The first three design activities are linear leaf pattern, honeycomb gridded pattern, and the third one is 360-degree radial kiwi fruit pattern. So these three designs are common to all. That means through these three activities, I am promoting the concept of collaborative learning. I divide the class into three groups based on their roll numbers, assuming a class of 15 students. I'm not considering any gender, I'm not considering any other factors. Just based on the roll numbers, I'm dividing the, say, let us take 15 students. I'm dividing the class into three groups. Okay, based on their roll numbers, assuming a class of 15 students with one group consisting of 5 students. Okay, and I will give the activity of linear leaf pattern to group 1, and gridded honeycomb pattern to group 2, and kiwi fruit radial pattern to group 3. Okay, so those 5 students are discussing their topic, and they are interacting with each other. And once they finished group 1 activity, then that group will enter into the group 2 activity. At the same time, the group 2 students will enter into the group 3 activity. The group 3 students will enter into the group 1 activity. Okay, so in this way, inside the computer laboratory, 3 activities will parallelly run inside the design and technology classroom. Okay, so once the group 1 students will finish their activity, they will uh, group then group 1 student will enter into the gridded honeycomb pattern activity. At the same time, the 360-degree radial kiwi fruit pattern, that group students will enter into the group 1 activity. Okay, so here another advantage is that so group 1 students already finished the linear leaf pattern activity. So now group 3 students are doing this activity, so they can interact with each other. If there will be a confusion, or if there will be a doubt, then they will discuss with each other so that they can work together, and they are collaborating each other, group 1 and group 3 students. At the same time, at the same time group 1 and see group 2 enter into the group 3 activity, right? 360 degree radial foot pattern. Group 3 already finished. Again group 2 and group 3, it is discussing the kiwi fruit radial pattern. So in this way they are interacting, they are collaborating with each other. So through this activity I am promoting the concept of collaborative learning. Okay, so there are various collaborative learning approaches. I'm not entering into all those details, like jigsaw, then fishbowl concept, then catch up. So these are the some of the different collaborative learning techniques, but I'm not entering into that topic now. Yeah. Self-assessment or evaluation group. So this is the evaluation group. So after finishing this activity, there will be three evaluations. One is self-evaluation, then second one is peer evaluation, and the third one is teacher evaluation. Self-evaluation means the student, once the student finished their activity, they have to evaluate their performance based on the evaluation rubric. They have to review the evaluation rubric, and they have to write their own score here. Total score. What is the total score? Based on the 4 different outcomes and based on this evaluation rubric, they should write their score here. So this is called a self-evaluation. Okay. Once self-evaluation is completed, say for example roll number 1. So roll number one is completed his activity, then the next step is to do the self-evaluation. Okay, once he finishes the self-evaluation activity, the next step is he 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 is going to visit the design of roll number 2. Okay, and roll number 1 student will evaluate roll number 2. This is what is called a peer evaluation. Okay, again they will discuss with each other. Okay, and see, there will be one problem. Because of this peer evaluation, there will be not peer evaluation also at the same time the collaborative, there will be some conflicts, there will be some fights inside the classroom. It is a duty of the teacher to 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 properly manage or properly monitor the students. Okay, there will be some conflicts, but that is mandatory not mandatory. But sometimes because see, 15 students having 15 different viewpoints, perspectives, maybe there will be some conflicts will happen. Okay, so this is what is called evaluation. So there are, I already explained self evaluation, at the same time peer evaluation, then finally the teacher will evaluate the performance. So teacher evaluation will be the third level of evaluation. Okay, the first level will be self evaluation. Okay, then peer evaluation, and finally the teacher will evaluate. Okay, so the teacher is evaluating the performance. uh, uh, there This is a three-stage process. The evaluation is a three-stage process. Okay, and the teacher evaluation is on the third stage. Okay, so just imagine there will be some improvements in their particular activity when the teacher will evaluate his performance, right? Because because after self evaluation they will correct something. Then the second level will be peer evaluation. During the peer evaluation also they will correct something. And finally the teacher evaluation. So there are improvements, there are positives if we are implementing the concept of self evaluation, peer evaluation. This is very this is very useful, and this is very relevant in a collaborative learning environment. Okay, then this is a sample evaluation sheet I have completed, and here you can see uh, the student name, his class, his roll number is written here, and these are the scoring points, and these are the student scores based on the performance, and this is the score out of 16, 9 out of 16. Okay, so this student scored 9 out of 16, this student scored 12 out of 16, and this student scored 13 out of 16. Okay, and out of these three students, this student is a good computational thinker, and this student is not that much range uh, related to the concept of computational thinking. Okay, so next is the sample of students work. So this is okay, so this is the Tinkercad code blocks. So here you can just click and drag. Okay, and here there is a play button. Click the play button, you will get the output here, you will get the design here. Okay, this is a again, this is from nature observation, and this is a linear leaf pattern. That means one leaf is repeating linearly, okay, in one direction. That is what is called a linear leaf pattern. Okay, and this is another example. This is another example related to linear leaf pattern. This is a building. Okay, and this is a linear leaf pattern, and you can see this is x-axis linear leaf pattern, whereas this is y-axis linear leaf pattern. Okay, and here you can see the variables. Okay, you can see the repeat block. Okay, I already told you in the evaluation rubric, one outcome is you should use repeat block, count with block, etc. Okay, so here you can see the the repeat block. Okay, yeah, correct. Okay, so these three designs are common. These three designs are common to all the students. These three designs are common to all students. Okay, so this is their first activity. Through this first activity, through this collaborative learning approach, they will understand the tool. Okay, because they are first time they are using this tool, they have to they have to they have to understand the tool first. How how what are the commands? Okay, and what are the different types of syntax, how I can arrange the blocks in a systematic manner. So it takes some time. So giving a common activity to all the students will help them to understand the tool very systematically. Okay, so they are understanding the tool very systematically, and they are preparing these three designs: linear leaf pattern, honeycomb gridded pattern, and 360-degree radial pattern. Okay, then coming to the instructions, you must follow instructions and complete tasks within the allotted time. The first step for students is to carefully review the evaluation rubric and plan their activities accordingly. Okay, so after finishing this session, I will give you the evaluation rubric. Okay, I will give you two evaluation sheets. One is for self-evaluation and one is for peer evaluation. Okay, and roll number one should evaluate roll number 2, whereas roll number 2 will evaluate roll number 3 will evaluate roll number 4, like that. So this is called a peer evaluation. Okay, and you have to return these two evaluation sheets after finishing the self-evaluation activity and peer evaluation activity. Okay, so okay, first you carefully review the evaluation rubric and plan your activities accordingly. Then the second one is the submission of a comprehensive report. The next step is to conduct thorough research and create a well-written document titled Computational Thinking to submit to the instructor upon completion of the activity. So uh, you can prepare a written document, or you can prepare a soft copy uh, document. Okay, you can use any approaches. Either you can prepare a well-written document, a handwritten document, or a computer, or an MS Office document. Okay, no issue. The first three activities will be same for all students, while the next three will be based on the nature observation by the student. Okay, so the first three activities are common, but that is to promote collaborative learning, and the next three activities will be different. Okay, that is to promote the concept of independent learning. Okay, and about the score, the minimum score for this activity is 4 and the maximum score is 16. It is the responsibility of the student to aim for the highest score. I already mentioned in the evaluation rubric, the maximum score is 4, that is advanced or mastery range, that is 4, and there are 4 outcomes I am measuring. So 4 into 4, 16. So 16 is your maximum score and 4 is your minimum. It is your duty to score maximum. After finishing the activity, so we are using the tool called Tinkercad. Okay, so there are 18 activities in Tinkercad. So after finishing these 18 activities, you will be an expert. You will be an expert in the area of design and technology. That is the that is the ultimate objective, or that is the ultimate intention of me. Understand? So once you finished this computational activity, then we will start with the LED blinking circuit with Arduino. Okay, we will learn the basics of robotics. We will learn the basics of C++ programming. We will learn the how you will program on Arduino. Okay, so you will download the software. You will upload the program. You will compile the program. You will troubleshoot the program. Okay, so you will learn those types of activities, those types of things in the next activity, that is called LED blinking circuit using Arduino. Okay, so like this there are 18 activities in Tinkercad. Once we will finish these 18 activities, then we will enter into the next tool, that is called SketchUp. There are 22 activities in SketchUp. We will do the after finishing the Tinkercad activities, 18 Tinkercad activities, we will enter into the next uh, level of SketchUp activities. So there are so many expectations, but I'm listing some 14 expectations from you. uh, Documentation skills. You have to submit a comprehensive report to the instructor. So your documentation skill. Okay, after finishing this activity, you will be able to prepare a comprehensive report. Okay, after finishing any activity, you will be able to prepare a comprehensive report to the instructor. So that means you will be able to share your idea to the outside world through documentation. Okay, so everybody can refer your document. your your juniors your ju- your juniors will refer your document. See, we are using textbooks, right? Who wrote the textbook? Some experts in that particular field wrote the textbook, right? And we are referring that textbook. If the textbook is not available, we are not able to refer. Understand? So your document is a valuable document, and your juniors will refer your document. Understand? So the documentation skills are very, very relevant. Again, it promotes the concept of independent learning, a research oriented mindset. Hmm? So these are the intentions behind the documentation activity. Ethical consideration. See, we are doing anything. Ethics is a very, very very, 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 very important thing. Okay, don't do any unethical things. Okay, only do ethical. So ethics is very relevant. Okay, then networking. Okay, so we are living in a social environment. So we should interact with each other. We should share our ideas with each other. We should convey. We should share the solution of a particular problem to the outside world, so that customers will get the benefit. So through this, we have to improve the skills of networking. Networking means We all are networks. I am connected to you, you are connected with other people, and he is connected with this boy, this boy is connected with me. So we all are interconnected. Okay, like like a network. So networking, connecting, working with peoples, these are very important. Then a research oriented mindset. Again, this is promoting independent learning activity. Communication skills. You are communicating, you are sharing your idea to the outside world through proper communication. Through collaborative learning, your public speaking skills will improve. Your active listening skills will improve. Entrepreneurial skills. You are thinking like an entrepreneur, like a business person. Then project management. You have to complete an activity within a particular within. See, anyway there will be a limit, a time limit. You should follow the time limit. You should follow the time limit. You can't exceed. Okay, a project, you have to complete a project within the time frame. There will be a time frame. We have to complete the activity. We have to finish the activity within the time frame. Collaboration. I already mentioned we are living in a social environment. We have to collaborate with each other. We have to interact with each other, sharing our ideas, giving criticism, taking criticism. Then coding, programming. Then learn new technical skills. Thinking, design thinking, understanding the problem, design new ideas, new products, new services to the customers, using your creativity, innovation, thinking out of the box, critical thinking, asking evidence. Why you are saying like this? Where is the evidence? Show me the evidence. Solve the problem, understand the problem, define the problem. So these are some of the expectations from you after finishing this activity. So I'm concluding. In this particular activity, the students were introduced to the idea of computational thinking, which is an approach to problem solving that involves breaking down complex problems into smaller, more manageable parts. You are breaking down the problem into smaller sections. The term is manageable. The, the complex the complex problem is difficult to manage, but you are slicing the problem. See, I'm giving you 1 kilogram of uh, cake, and I am saying, eat this cake. Is it possible? No. If you are slicing the cake into smaller pieces so that you can easily eat the cake, the same thing means manageable. You can manage the section. Here in computational thinking, the aim is to break down the problem into manageable parts. This technique allows for a more logical and systematic approach to solving problems, which is essential in various fields, including computer science and engineering. Through this activity, the students learned about the different components of computational thinking, such as abstraction, decomposition, pattern recognition, and algorithm design. They also had the opportunity to apply these concepts to a real world problem. Okay, so our activities, see, there are 6 design activities, and these 6 design activities are from the nature observations. That means we are connecting the classroom into the real world, or we are connecting the real world into the classroom, which helped them to understand the practical implications of computational thinking. Overall, this activity provided a solid foundation for the students to build upon as they continue their education and pursue careers in the fields that require strong problem-solving skills. There will be an exhibition after finishing each activity so that the students can share their designs to the community and collect feedbacks, and it will be a great motivation for the next activity. So with this, I am stopping my session. So thank you for your patience. Thank you for your listening. Thank you.